metal wings to fly won't take you to the stars. Use the metal for a boat and you won't sail too far. Stop sitting in the dark, stirring metal pots about. You will change your life forever when you figure out the secret PinCode, 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 PinCode. Science can be tricky, it can overheat your brain. Science can be hard to chew, each bite can be a pain. Stop sitting in the dark, stirring metal pots about. You will change your life forever when you figure out the secret PinCode, 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 PinCode. The secret PinCode, 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 PinCode.
You know something, Daco? When I said that I needed more space, I didn't mean this much.
Space is the final frontier, Wally, and we have a goal. Our goal is to find water somewhere else in our solar system before anyone else does.
I found water in our faucet.
He has a point, though. What good is water in the void of space?
You should show more respect for the most important thing on Earth.
Water is one of the most beneficial substances on our planet. It covers 70% of the Earth's surface, but 97% of that is salt water from the oceans. Only about 3% is fresh. That's the stuff we drink.
Holy carrots, just 3%, huh? Guess maybe I should start drinking ocean water.
Listen up, guys. We are not looking for water to drink. We're looking for water out in space because it's absolutely our best chance of finding alien life.
Whoopee! Why would there be aliens?
Scientists believe that life on Earth could have started in the water. They think it might have been helped along by electrical charges in the water. So it's possible life can start on other planets in the same way. Earth used a combination of methane, ammonia, and hydrogen in our ancient atmosphere. With a little electric discharge, amino acids can be formed, which create proteins, and proteins create life as we know it. Water doesn't just provide a good place for proteins to form, but also protects them. And water can help animals' bodies, including our own, regulate temperature in the same way clothes do. Fluctuations in our Earth's weather may seem extreme, but really, water helps keep a lot of things regulated. Water helps keep our bodies cool when it's hot outside, and it always helps to stay hydrated. In the same way, a pond or a lake that freezes on top is actually helping to preserve the life beneath the surface. The fish inside stay nice and cozy.
Whoa! It's wearing a hula hoop!
No. See, these are planetary rings, and this is where we're going.
You're hunting for water on Saturn?
Not quite. We're going to one of the many moons of Saturn. It's called Enceladus, and it's one of Saturn's smaller moons. It's only about 300 miles in diameter.
Encela, what now? Why don't we just try the moon? I hear that's a lot closer.
We're going to a moon, just not our moon.
Though Saturn has many interesting moons, Enceladus is especially unique. Its surface is almost entirely white due to the fact that it's covered in what we believe is watery ice. The icy surface makes it extra reflective, which means that despite its small size, we can see it extra brightly in the night sky.
Wow! Awesome! Look at this snow! We can make a sweet fort!
Oh!
Sorry, friends, but I believe making a snow fort would be impossible on this moon. The temperature is more than 300 degrees below 0 Fahrenheit, That also means none of you can move the ice or, incidentally, remove your spacesuits.
Even my horns are frozen. What could possibly live here?
Nothing up here, but below us, who knows? Scientists have observed that though the surface may be several miles of ice, beneath the surface might be much warmer. Can you imagine? And if it's warmer, there might be water underneath. And if there's water, there might be the very foundation for life. Oh my! Come look! My seismograph detected flows beneath the surface! This is amazing! This proves that there's an underground ocean!
Run, Wally!
Hurry,
Hurry!
Wally!
Get
Come
over
on,
here!
hurry!
Move!
Go,
Let's
Wally,
go!
now!
Good morning, Wally.
Oh, what happened?
What happened is that you discovered one of Enceladus's geysers, and these were found originally by the Cassini probe when it flew by this moon back in 2005.
Splendid. I'm late to the party. Now, can we go home?
We can't leave yet. We had to be proper scientists and send a probe into its underground ocean, and that probe is us.
We're what now?
That's right! We're more than 60 miles beneath the surface of Enceladus. We should be basking in the glory that we're on a moon where no astronomer has ever been before.
I'd rather be basking in the sun, specifically on the Earth.
I still don't understand. What's so special about this place's water? It just looks like water to me.
Water is called H2O because of its chemical makeup. It has 2 hydrogen atoms and 1 oxygen atom. These molecules are attracted to each other, and when a bunch of these molecules gather, it makes a liquid, water. They change their position a lot, which is why liquids can move and flow. But when the temperature gets too cold, specifically below freezing point or 32 degrees Fahrenheit, they snap together in a hexagonal shape. This way, they're no longer a liquid, but a solid, ice. The spaces between the hexagons means that ice is less dense than liquid water. That's why it floats. In its liquid form, water can reflect electromagnetic waves. Maybe that's why my cell phone doesn't work when I'm scuba diving. Anyway, water protects us from so many things, whether it's in liquid or solid form.
Do you see it, everyone? It's all the ingredients for life!
Well, I see a terrifying darkness, but, you know, same thing, I guess.
We won't be able to see life with the naked eye. But if we can get something under a microscope, we just might be able to find even the tiniest of cells. Even that would be a huge breakthrough!
Huge breakthrough!
Aliens! Alien life outside our ship! Holy carrots! Here, calamari, calamari.
I think there's something watching as we invade their planet!
We have to get out of here fast.
Yeah, in a sec. Here, fishy. Here, fishy. Aha! Gotcha, you little alien fish!
Are you crazy? Crash is still out there.
Amazing! We learned so much, but so much is unknown.
That whole finding life thing might be bigger than we thought.
Good morning, Wally.
Daco said that you actually discovered a geyser out there on Enceladus. But then he said actually this probe called Cassini flew by in 2005 and found it first.
Fabulous. Still late to the party. Huh? But wait! We were in the ocean, and Crash went out to catch it. There was a squid. Well, not a squid, but a scary thing. And there was a giant, thing.
Don't know. But while you were sleeping, we went in the ocean. All we found was water samples, but we gave those to Daco, who's checking them out now.
We didn't find any squids or giants, just murky water. It was cold.
If none of that really happened, then that means I understand.
There's life on this moon!
Huh? It's not as exciting, but at least it's not attacking us.
It's incredible! This is Nobel Prize stuff! You see? We found life out in space! So amazing! Wally, we need to head back to that moon right now and get more samples! Impossible! Where'd it go?
Where did what go, Daco?
Enceladus! It's gone! An explosion? Or a meteor? It doesn't matter, I guess. But the whole moon it's just all of it gone.
Don't be sad,
At least we have
Daco.
our samples.
Hey, you want to look
That
for water?
proves something,
I bet we
doesn't
can
it?
find water in the kitchen.
What?
Enceladus is a real moon of Saturn, though it's one of the smallest. This episode was fictional. Enceladus is doing just fine and definitely hasn't exploded. Scientists think there might actually be an ocean of icy water on its surface, though. And who knows what may lurk beneath.
Earthling, the Plutonians give you thanks. You are a hero to our tiny planet. However, your own planet is an enemy. When the sun rises, our armies will descend upon your Earth and destroy it.
No! Wait! You can't do this! They were just a few bad spacemen! You can't punish all of us for them!
Your comments are noted, hero. We'll think about it.
Oh.
The Plutonians greet their hero with respect.
Hey there.
We have reached a compromise regarding your planet. The Earthlings must pass our intelligence test to prove their right to not be destroyed. Uploading now. We expect our answer within 1 week's time. We will return then for the judgment.
I don't...
Good luck.
And we only have a week. If we all work together on it, we might just be able to solve it. And then we can save the planet!
So, what is this test exactly?
Well, I haven't figured it out yet, but I'm close. I have a few ideas. Well, some very small ideas, that is.
Is this test made for ants?
Incredible! The Plutonian language is like them. It's so small. I'll need a more powerful microscope.
Your average optical microscope has two main portions, the object lens and the eyepiece. The lens gathers visible light that bounces off an object, magnifies the image, and lets us see it through the eyepiece. Microscopes are super cool and can let us see a whole world of things that are too small to see with the naked eye. They can enlarge things up to 2,000 times.
I just can't figure this out. It's too small for me to see.
You have a weird sense of humor, friend, but April Fool's is a long way off.
But wait a second. None of you guys believe me?
About the aliens? Are you sure it wasn't a weird dream?
I'm hoping this is all a weird dream. And that my friends didn't wake me up for this.
So these alien guys, they wanted us to prove our, whatchamacallit, smartness, right? But I bet we can beat these aliens, whatever you call them.
Plutonians.
Oh, gesundheit.
No, this isn't fun. This is of utmost importance to our planet's future. Don't you all see what I mean?
Taco, we all enjoy a good prank, but next time let us sleep.
Whatever's written on the test is too small to see with our current technology. I have to be calm and rational about this. No need to be discouraged. If we work together, we can get this. I might need sleep. Go back to the microscope. Why do you think it doesn't go as small as you want it to?
Light travels in waves. All these light waves have a wavelength, or a distance between the waves. Visible light has a minimum wavelength of 380 nanometers. Visible light is how we're able to see objects. The waves bounce off and go back to our eyes, but the object has to be bigger than the size of the wavelength. If it's not, the waves simply pass over it, and that's why we can't see things that are super small.
If you want to see smaller wavelengths, why don't you try radiation? We still couldn't see it. Our eyeballs just aren't capable. Easy. Then just project the findings onto a screen. Zoom in on it. You'll be able to see it. You are a genius. I'm a genius. Listen up, everyone. I've invented something that proves Earthlings have intelligence once and for all. The electron microscope.
Oh!
The electron beam comes from a tiny point of super hot tungsten. The beam, just like regular light in an optical microscope, gets focused by a special electromagnetic lens. Then, the electrons fly around through the sample at super fast speeds, because they're electrons, of course, and create an image. This image is shown on a screen and enlarged several thousand times. Whoa! Look at all those crazy things. Thanks to electron microscopes, we're able to see all kinds of things way smaller than with an optical microscope. Thanks, electrons.
With this, I can finally see how those Plutonians plan to test our intelligence.
He's still talking about the aliens?
Taco needs a serious nap.
I missed the memo. What are we all doing here?
I don't understand. I made the image larger, but there isn't any message like I thought there would be. Any smaller and we're talking nanoparticles. I don't have anything that can do that. I've failed our whole planet.
Taco, relax. Why do you worry so much? When's the last time you slept?
I can sleep when the planet's safe. There's only 3 days left until the Plutonians said they'd destroy us. I'm a dummy.
You're hardly a dummy. A dummy wouldn't have been able to create the technology you have in such a short time. And I know some dummies. If the Earth is going to be destroyed, who says you have to save it?
All right, drink this. You need to relax, Daco. I had an uncle who talked to aliens. We called this his crazy juice. It'll put him right to sleep, like a baby. No more aliens, for sure.
It seems you are late, hero.
Uh-oh. Oh, can we talk about this?
Maybe there was something in Daco's story. Get off my tail feathers!
Save me! They've got me! I'm blind! Oh. I've got it! My microscope! If we're not able to see something, we should be able to touch it, but on a molecular level. If we made something we could control with our hooves or flippers, we could see way more on the tiny scale than we ever could before. I'm fairly clever if I do say so.
Even though electron microscopes are amazing, there's still some things they can't see. That's right, too small even for electron microscopes. When that happens, we need the use of nano-objects to help us out. Nano-objects can help us by touching the tiny thing we're looking at. It's so sensitive we use something smaller than the point of a needle, and scientists are able to move it along the surface of the object. It reacts to the nanoparticles in a way that lets us see the surface. The needle uses a laser to project the image, and voila! Now we can see extra tiny nanoparticles.
And that's how we'll read the message, with nanoparticles!
Hero, what is your answer on behalf of Earth?
It is 4.
Is that your final answer?
Yes, it is.
The Earthlings are correct.
So, heard from any aliens lately?
That's all good now. We're safe. I answered them.
You are weird. Still not April Fools.
Huh?
In 500 kilometers, turn to the right.
Yep, will do.
In 300 kilometers, turn to the right.
Thanks very much, but I heard you the first time.
Checkmate! Are you sure you know how to play this?
In 100
Great
kilometers,
flaming carrots,
turn
what
to
is your
the right.
malfunction? How many times are you gonna say it?
You have missed the turn, flawed carbon-based being. But there is another turn in 300
Why
kilometers.
didn't you say something, you piece of junk?
That's a bit of an overreaction, my dramatic friend. Global satellite navigation is an intelligent and super helpful invention.
The only thing it's good at is being super annoying.
Remember, before GPS, we had to use less advanced and less accurate means of navigation. It was crazy. For instance... He should be back by now. I hope there hasn't been an accident. Oh, what if something has gone amiss?
Sweet sauerkraut! Base, come in, Base. Condor here. Base, it's Condor. Do you read me?
Base right here. Hello?
Base, Condor here. Flight test is underway. Do you read me, Base?
I'm so glad to hear that.
I'm currently flying over the desert. There's a bit of a dust storm. My compass... it's damaged. It's hard for me to tell exactly where I am.
Come again? Am I to understand? You're really lost?
Well, I wouldn't say I'm not lost.
Thank you, my friend. I know you're very brave and ready to help, but the desert is simply too large, and we have no idea at all where Pin is. It'd be like looking for one particular grain of sand on the entire beach. Excellent thinking! What a wonderful idea! That's called inversion method, solving the problem through contrast.
Reverse reasoning, or backward chaining, is a way of thinking that turns your problem upside down, working from a goal backwards to the start to find out what to do.
It's much easier for Pin to look for us than for us to look for Pin. To put it simply, Pin needs to find the right direction to get out of the desert. Right. Sure, it's tricky with no compass in the middle of the desert, but explorers of the past used to find the right way somehow.
Since the horizon is continuous, if you know one direction, like which way north is, you can figure out all of the others based on that one you know. If you get lost and you don't have a compass, the position of the sun can play that role for you. For instance, in the northern hemisphere, the sun rises in the east, arrives in the south around noon, and sets in the west.
Hey, look at that!
Ah, yes, nighttime. Well, at night we have... almost. We have the polar star.
Groovy, danke!
The North Star, or Polaris, shines above the Earth's true north. It can be found at the end of the Little Dipper's handle. To find it, draw a line from the front two stars of the Big Dipper straight up to the end of the Little Dipper, and there's Polaris, the North Star. Now, if you can't see the sun or the stars, you can also find your way by things around you in nature. Moss or lichen covers stones and trees on their northern sides. Tree bark is harder and darker facing north. And anthills are usually located north of tree stands, and the southern side of the anthill will be shallower than the northern one.
Alrighty, still lost.
Condor, it's Base! I've got grand news for you! If you don't have a compass, you can always find your way by using the stars. Or anthills. I'll explain how.
Nicht for stars, nicht for hills events, nicht for everything, except for the sand. And that there's a lot of.
Think. There must be a way. Nothing's impossible. Except, of course, for all the things that are impossible, of which this is not one. Ha! BB, forget old-fashioned methods. Did you know it's possible to determine where a person is with the help of satellites up in space?
Satellite navigation can determine someone's location with amazing accuracy to within a few meters. Small electronic receivers determine latitude, longitude, altitude, and achieve time synchronization. Satellite navigation has 3 segments. About 24 satellites, give or take a few, form what's known as the space segment. The control segment is an intricate network of antennas at monitors and control stations on the ground. And the user segment is an electronic receiver you hold in your hand or carry in your vehicle. The 24 satellites are about 20,020 kilometers above the Earth. They are divided into 6 groups, 4 satellites in each one. Each group of 4 satellites moves on the same orbit and makes 1 revolution around the Earth in 12 hours. By dividing all of the satellites into equal parts, there are at least 4 satellites positioned over each segment of the planet at all times. To determine location, a user's receiver determines the distance to 3 visible satellites. The distance to one of the satellites is x, so the receiver can be placed in an imaginary green sphere with its center at the point of the satellite location and x radius. The receiver then measures the distance to the second satellite, and here's another sphere. The receiver can then be placed at the point where these 2 spheres intersect. For clarity, let's make it red. Having calculated the distance to the 3rd satellite, the receiver constructs the 3rd sphere and determines 2 points of its intersection with the red circle. As you can see, one of the points is in space, so we can discard that. And using this method of triangulation, we can determine exactly where the receiver is.
What do you recommend, my mechanical friend? Will we be able to successfully construct enough satellites to pull this off? Let's see here. 1, 2, 3. Exactly the number needed for Pin to determine his coordinates.
Each satellite carries 4 atomic clocks that work to an accuracy of 1 second in 20 million years. And every satellite creates its own unique impulse sequence. The user's receiver gets this impulse sequence with a delay that is equal to the time needed for the signal to cover the distance between receiver and satellite. So to determine location, the receiver must measure 3 signal time delays from 3 different satellites.
Z2! Dum 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 dum.
Know what, GPS? I think you're pretty cool after all. So how about it, friends?
You have missed the turn again. Unbelievable. There is another turn in 3 million kilometers.
That's it. We're replacing you with an anthill.
Phenomenal! When we look through the telescope at faraway planets, stars, and galaxies, we're looking not only through space, but also through time. The light that we can see needs some time to reach us. When we look at the sun, for example, we actually see it as it was 8 minutes ago. That is the exact period of time that it takes for light to cover the distance between the Earth and the sun. Taking a photo of the closest star, Proxima Centauri, gives us an image that's almost 5 years old. So we see faraway galaxies as they were millions of years ago.
Wunderbar! So you're saying when we look at the stars, we see not only far away, but back in time?
Precisely, yes.
Space is just really boring.
But Crash, you're the one who wanted to come.
You're right, I did. But I was thinking we'd meet cool aliens and stuff. Have battles with guns that say pew, but there's nothing out here. Nothing but empty space and twinkling stars. And we could see that stuff from Earth.
Daco thinks that we're pioneers, trailblazers here at the dawn of space discoveries. That means every space experiment we do is of great value to the future. When you think about it, it's exciting.
Right. That's about as exciting as math. I want some space pirates. Pretty please. Ah. Well, look at that. That'll work.
Crash, are you sure this wasn't, important?
I'm making it better.
Colleague, please be very careful. This is a crucially vital experiment.
Yeah.
System ready to start.
All right, cunning invaders from the long-ear cottontail cluster. You will not last very long up against Captain Fuchsia's spiky head.
Give up, creatures of the Earth. Swear your allegiance to the cosmic carrot or else perish.
A firm no.
Fellas, since you're not doing anything that matters, come on up! We've found something awesome! Just phenomenal!
So, what's so awesome and phenomenal?
Right there! Right there! Our sun.
The sun is the star that binds our solar system together. Everything in our system revolves around the sun. The 4 terrestrial planets, 2 gas giants, 2 ice giants, and all their satellites, and the asteroids, meteorites, comets, and space dust as well. The sun's mass makes up 99.8% of the whole solar system's weight. Our ancient ancestors recognized how much their survival depended on the sun. Because of this, there were many ancient cultures that worshipped the sun. While our understanding of the sun's properties and processes has grown, and we no longer worship it, its size and position in relationship to the Earth remain vital to the survival of life on our planet. If the sun were any bigger or closer, Earth would be too hot for life to exist. And if the sun were any smaller or further away, Earth would be too cold for life to exist. While the sun is the biggest body in our solar system, in comparison to other stars in the universe, it is an average-sized star, sometimes called a yellow dwarf star. The closest star to our sun is Proxima Centauri. It's about 1/7 the size of our sun and is 4.25 light-years away. That means the light from Proxima Centauri takes 4.25 years to reach Earth. Sirius, which is 2 times heavier than our sun, is 9 light years away. And Arcturus, which is 25 times bigger than the Sun, is 36 light years away. The largest nearby star is Betelgeuse. It's 1,000 times larger than the Sun and is 500 light years away. Our Sun is about 150 million kilometers from the Earth, or about 8 light minutes away. Today we know a lot about the Sun, and scientists are always searching for more knowledge. We know the age of the Sun, its radius and weight, though visiting the Sun ourselves is still a long ways off.
So what? You know you can see the Sun from Earth, right?
We're here for more than just a regular old gander at the Sun. We're about to conduct a very important scientific experiment.
What do you plan on looking at the Sun with? A nerd telescope or something?
Nothing like that, my bored, floppy-eared friend. We're going to be trying out a brand new, exciting method of traveling in space.
What's wrong with the old one? Besides, you know, that it's old and stuff.
When night fell and our ancient ancestors could see the stars, some dreamt of exploring space. Throughout history, people discovered new and better ways to travel by land, by water, and eventually even by air. But airplanes rely on atmospheric pressure, so when we pass through our atmosphere and into space, there is no pressure to hold us up. We need another way to move ourselves through airless space. The answer to our problem was jet propulsion. Propulsion relies on Newton's third law of motion, that to every action, there is an equal and opposite reaction. Propulsion shows up in the animal kingdom. For instance, an octopus will propel itself along by sucking water in and then pushing it out. This propels the octopus through the water. Another example of propulsion is the motion of a boat when a person pushes off of it to jump in the water. The boat reacts to the pressure of the jump and moves away from it. Motion occurs in space because the rocket uses an expulsion of fuel to push itself forward. No air is necessary because the rocket is responding to the opposite pressure of the fuel. A rocket must have enough energy to escape the Earth's gravity. At liftoff, the rocket's thrust is created by solid rocket boosters pushing upwards. Russian scientist and physics teacher Konstantin Eduardovich Tsiolkovsky played a key role in the development of jet propulsion by suggesting multi-stage rockets. Multi-stage rockets drop off sections of the rocket as the propellant is used up. This decreases the mass of the rocket, making it easier for the next propellant to push the rocket even further.
Groovy as jet propulsion may be, it has one very serious drawback.
What drawback? Look at it! It's awesome!
To get very far using a jet engine, you'd have to carry way too much fuel.
But how do you fly once your fuel supply runs out?
Well, we might run across something that can give us a little push. For example, the sun.
For real? Holy carrots, How is that?
Not quite, because the sun hasn't any hands, but it can push all the same with its shining light. Pretty interesting, am I right? Light puts pressure on the items that it hits. Only a little pressure, and yet, out here far away from gravity, that tiny pressure just might help us.
Peter Lebedev, a Russian scientist, was the first to measure the pressure of light on a solid body. He took a silver thread, placed a small foil propeller on the thread, and then placed this into a glass flask. He then removed all of the air, and when he directed light from a lamp on the flask, the blades began to spin. Almost 400 years ago, German scientist Johannes Kepler suggested that a solar sail might be used for traveling through space one day. Different space agencies are now planning and building some spacecraft with limited solar sails. But to explore interstellar space, we would need to build sails that are many kilometers across.
But of course, then they didn't have the technology for the creation of the large-sized cloth solar sails required, and so the concept was put on hold until a more advanced era.
And that era is today. We have been able to fabricate a solar sail prototype with the required size and properties.
Solar sail is damaged. Attention, solar sail is damaged. Attention, sail is damaged. Hello? Is this thing on? Your sail is messed up, yo.
Stop the deployment process! If it spreads out in its current state, the solar sail could be ripped to
I
shreds!
can't stop it! The process is automatic once you started it!
We've been preparing this for months! A one-of-a-kind experiment! Months of careful preparation! Oh, months! Not weeks, not days.
Hey, I was hugging that.
I don't know if this matters, but unauthorized spacewalk in progress.
Just let me get us a better picture!
It's Crash. Look!
The sail is still spreading out! Danger! That is dangerously dangerous!
Solar sail 75% deployed.
I find this very stressful.
Huh. Solar sail successfully deploying. The bunny rabbit did it.
Phenomenal! All right,
That's
Crash!
my resourceful
Wonderful
brain,
work, dear
Pepper.
friend!
Fluffy tail.
Come back inside! I want to shake your hand! What?
This looks like a job for jet propulsion. Yahoo! Oh, oh, oh.
Solar sail completely deployed. We are sailing on the solar wind.
Oh, these cluttered up boxes. Whew, I haven't got time to dig through all this. I should just throw all this garbage away.
What kind of book is that? Looks like it's really ancient.
It's my dear great-grandmother's scrapbook. She was enthusiastic and eccentric, a survivalist. She said that when the world finally falls apart, I could be the one to step up and save it. So she prepared me for great achievements. While other girls were playing with dolls, I was training to meet great-granny's standards. I haven't saved the world, but I'm still in pretty good shape. Look, 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 look. Oh.
World falling apart? Stepping up to save it? What's that about?
Granny told me everything was explained in the book.
Clouds on fire, magnetic field, inversion. Golly! Why have the bees gone crazy?
More, more! To me, to me! Right, right! A little left, yeah? That's it! That is just great! That is perfect! That is... Stop, stop, stop! Feng Shui says your bed should be facing north.
No, this thing is saying north is there!
This way, just a little more this way. Oh, it's gonna be perfect. This way.
Hi there! Have you ever heard of something called the magnetic field?
Everybody has seen normal magnets at least once in their life. Sure you have. Look at the front of your refrigerator.
All right.
Every magnet has a north pole and a south pole. Similar poles repel each other, and opposite poles attract each other. This happens because particles within the magnet create electrical charges, and those charges create a magnetic field. That field of one object can attract other objects with a magnetic field of their own. Our own planet Earth behaves like an enormous magnet and has its own magnetic field. We can't feel it, but it affects all life on Earth.
I can't feel it at all.
Well, one way we can use the Earth's magnetic field is with a compass. Compasses work because the magnet in a compass aligns with the Earth's magnetic field. The magnet in the compass lines up with Earth's south magnetic pole, which is what we call our North Pole, since opposites attract. Compasses have been used for navigation for about 1,000 years. Do you know how Earth's magnetic field is generated? Let's dig down and see. About 3,000 kilometers down. That's where our planet's inner core is located. It's almost as big as our moon and composed primarily of iron. This, coupled with the planet's rotation, helped produce the Earth's magnetic field.
But nothing bad would happen if the magnetic field disappeared, would it? Because after all, we can't even feel it, right? And nobody really uses compasses for anything now.
Look at this! Look at what my bees did! They made this instead of normal honeycomb. Huh, what do my bees think, they're artists now? Darn thing looks like some kind of sculpture.
In the same way that wood mice find their way in the forest using the Earth's magnetic field to navigate, and migrating birds use the magnetic field to stay on course through long flights, bees are also highly sensitive to magnetic fields. Bees arrange their honeycombs according to the Earth's magnetic field. They also base communication and navigation on the magnetic field. Without Earth's magnetic field to guide them, the mice, the birds, and the bees would go from order to chaos immediately.
Confusion will claim the birdies, poor things. Also, the bees will forget how to build. But what's the magnetic field got to do with the animals?
Let me take a peek at that and I'll answer you. Very interesting, fascinating, amazing, life-changing. Well, smack my rack! We're all doomed! We need a miracle!
No, jumbo-size no, with extra no sauce. I swore off all this rubbish a long time ago. I'm not that dumb little girl buying into that save the world garbage anymore. I live in reality now!
Please listen! You need to understand, not little girl. We're on the verge of a catastrophe! The Earth's magnetic field is disappearing!
Your great-grandmother knew this was coming, but she also knew the way to fix it.
But I don't remember much of anything my great-grandmother said to me. Hey, wait. I remember something about taking a trip to, I think, the North Pole. Why would she want to take a little girl on a difficult trip up into the frigid Arctic Circle? Pellets! What's that?
Oh, clouds on fire, just like it says in the book. It's another omen coming true.
Northern Lights, Aurora Borealis. They're never supposed to be visible in this place. The magnetic field is clearly weakening.
Tell me, what will happen when the Earth's magnetic field is completely gone?
Well, many animals and birds will lose their sense of direction. But that's just the beginning. It gets worse.
Our sun produces a constant stream of charged particles, commonly called the solar wind. This outflow of radiation from the sun races through the solar system at about 2 million kilometers an hour. Without the Earth's magnetic field, these supercharged radioactive particles would travel into the cells of living organisms, causing deadly diseases and mutations. Fortunately, that doesn't happen. That's because our magnetic field works as a shield. Dangerous particles don't hit the Earth's surface because they are forced by the magnetic field to flow around the Earth. Some particles do enter at the funnels over the poles. These particles, colliding with our atmosphere, are what produce the northern lights or aurora borealis.
We've been flying around this Arctic thingy forever. What are we looking for, huh?
I know. Great Granny could have left better instructions for this whole saving the world thing.
Look at that!
The Northern Brotherhood bids welcome to the Guardian.
Hey, brothers! Put her there!
Now, you will follow me. We have been waiting for you. Every indication is that the end is near.
And what exactly am I doing? Great-grandmother wasn't exactly forthcoming with details.
Your great-grandmother was one of an ancient Guardian family. Their vast knowledge was remarkable. They knew that once every several thousand years, the Earth's magnetic poles swap places.
Right! And this process is called, inversion. And as the inversion is happening, all the life on Earth will become extinct. The whole game's over. That's it. But it's impossible to predict when it might be starting.
There is not a single thing that is impossible for the Guardians, but there isn't anyone besides you that can activate the Great Northern Magnet, left by the Guardians to protect their descendants from the effect of the solar winds. Our Brotherhood has been protecting the magnet for centuries.
That is an enormous electromagnet. I've never seen anything like it before. Its electromagnetic field will be able to protect the whole planet from the solar wind.
We are ready to keep it working until the pole switch is complete.
Well, looks to me that you couldn't keep it working for 30 seconds.
But the device is in perfect working order. Must be some kind of trouble with the Southern Brotherhood.
Southern Brotherhood?
It's clear someone must activate the other device the Guardians built for us, the Southern Magnet. We must hurry! Earth's geomagnetic field grows weaker by the second.
This ship is too wetted to move.
I can't just wait. Great-grandmother trusted me to get this done.
The Southern Brotherhood bids the long-awaited Guardian welcome.
Nice to see you, fellas. Let's do this. We did it, Great Granny.